Okay, so in this video, now that we've got our Tic Tac Toe or noughts and crosses board working fine in the sense that we can place characters, we can make sure that they're only going into empty squares and therefore we are able to fill up the full 9 squares of the grid, we need to test the grid now to see if there are any winning lines. That's 3 characters of the same, either a nought or 3 characters of a cross, either in a diagonal or a horizontal or a vertical line. So that's what we're going to be doing in this video today. Okay, so if you haven't been here before, my name's Angela McCall. This is Point and Click Puzzle Games, a YouTube channel dedicated to helping teenagers and above learn how to program in the Lua programming language so that we can create our own mobile app games. But this programming language is also very useful for things like Roblox. So we have been on a journey of building our Tic Tac Toe or noughts and crosses game, and in today's lesson we are actually going to tackle now the ability to check our board status and all 9 grids to see if we can identify a winning line. That's either a line going across vertically or diagonally, and it's obviously got to be all 3 boxes the same character, so it's all going to be 3 crosses or 3 noughts, and that can happen at any point in the game. It doesn't just have to be once the board is completely filled up with characters. So as a person plays their character, we need to then run a quick check, and if that check comes back and it's the 3rd in a row, then the game can instantly be called a win for that player. Obviously the other one then loses, but obviously we also need to monitor what happens if we get to all 9 squares being completely occupied and there's nobody a winner. What happens when there is a draw or a stalemate, as it were? So this is what we're going to be covering in today's video. Okay, so let's jump on over to my left hand monitor screen. This is where we left it in the last video. Okay, so as we can see, we can play our characters all over the board and it doesn't matter what we do. I can't make it. Oh, there you go. There's a 3 in a row there, but we can still carry on playing, which is obviously not very good. So as a result, we need to now control this environment. And all I've done over here is I've turned off a lot of the print statements that were going on since the last video, just to tidy up the code a little bit more going on in our console. What we need to do now is actually identify, before we put a player's turn up here, so between these little statements down here, we now need to know if that means there is a win or if there is a draw. So what we need to do is call a function called, and I'm going to call, check, win, lose, draw. I'm just, because it can't get much more sensible than that. Copy, and I'm going to do the same thing underneath here. And because we know we're in the noughts and we know we're in the crosses, I'm instantly going to help myself out by sending the character over. So win, lose or draw for the character noughts, or win, lose or draw for the character, where have we gone? There we go. Noughts, crosses. Okay, so when this now gets called, we're going to receive in that particular character, so we know what we're actually looking for. So as I've got this crosses here, so as the cross is placed on the board, okay, we're then instantly going to say, actually, does that make that a winning line? Okay, and we're looking for crosses, in 3 crosses in a row. So we now need to create this function. So I'm actually going to come out of here because I think this is getting a little bit busy for us, and just before, I'm going to put a local function. Oh, there we go, character in, and I'm going to put an end statement. And like all of the other times I do this, just to make sure that we know that this is being accessed, I just copy the function name. Okay, so let's just hit save right now and make sure that this function is being called. So there you go, check, check. So both of them, there's only one of each character and we can see that it's being called. So we know that this process is now working. So let's minimize this down, and the first thing we could do is we could just make this a little bit more meaningful by printing the character's name. So I'm going to put toString there. Oh, I didn't want to put the quotes. There we go, my bad. and it's inside a double bracket. So save, and now what we should do is print to screen its crosses and noughts. So this is a lot more meaningful now to us. We definitely know which character is being played with. So ignore this message at the moment, because this might necessarily change now again because of the status of a win. So in this here, this is where we get a little bit more of a complex situation, because in order to draw a line has a start and an end, and therefore it has 4 points of reference. Okay, it's got an X and a Y value for its start and an X and a Y value for its end. So before we go any further else, we know that this little bit of code here works. I'm just going to go one step above again and almost copy the code that we've got for the functions up here. So let me just expand that so we can do the same sort of thing, but we're going to put a local function draw winning line. Okay, obviously when that happens we're going to have to do lots of different things, and again, just to make sure that it is working, let's just put in here print and then the name so we know it's happening. Okay, one of the problems that we now have is we need to check and see which boxes are creating the winning line. So essentially, is it box 1, 5 and 9, or is it going to be 3, 6 and 9, etc. So this whole formula now has to basically analyse patterns. Obviously, as we already know, the actual grid itself knows its own X and Y values, so we don't have to worry about that for just a moment, because we can get that information out of the square itself. So if we come back up to the square, we can see here it knows its X and Y position, and we know it knows its width and its height. So we can actually determine the centre point of it by the grids, okay, the actual square itself. So what we need to do is identify the first of all is which 3 squares create the actual winning line, and then once we know what those 3 squares are, we'll be able to identify a pattern and draw a line from the first square to the 3rd square, and so on and so on. Let's create our line first of all, just real quickly. So we've got a lot of the characters sorted out. So we're going to create a local line equals display dot new line. So if we quickly just refer back to our documentation here, we can go into the API reference. We're going to go to our display, there it is, and then we're going to actually create a line. Okay, so our new line, there we go. Here it tells us the syntax. So what we've got here is the parent group that we're going to put it into, which we'll need to just double check in a minute that we're making sure it's going into the correct group, and then the X and Y positions of point number 1, X and Y positions of point number 2. Now we're going to just draw a very straight line, but if you wanted to draw a star, for example, then it's going to have different points, and that's why you could carry on with this pattern of X and Y's for each different start and end of a line, but we're only going to need to use 1s and 2s in this example. Now that we have got this documentation, let me just slide this out of my way. Okay, we can come on here and finish this. So we've got a colour, and we are going to have to make sure we add it to the correct group as well. So the group that we're going to add it to, if we come right back up to the top of our code, we've got the foreground. Remember, this is where the X or the cross and the 0 live. So we're actually going to want to put our, I'm going to copy that. We're actually going to put our line in with the X and the 0. So the first thing we're going to do is going to put it into that function, and then it's going to have an X1, Y1. So that's the first part of the line, and then it's going to have an X2 and a Y2 for the end of the line. Okay, and that's pretty much all we need on that. If I just quickly take this code here, and we now take our line, we can give it a colour, and all I'm doing at the moment is copying that example that we had the other on the documentation there, just so that we've got something for the moment. So I don't really care what colour, we can style it in just a moment. Okay, so that's almost finished. The only thing that we actually need to do here now is receiving the different points. And what I'm actually thinking of doing, just to make it a little bit more easier for you guys to understand, so let me just put start X, okay, and then we're going to call it start Y, and I think this is maybe a little bit less confusing when you're trying to think about what you're doing. So the end X, and then we're going to put end Y, and I think that is more probably a little bit clearer for you to understand the start of the line and the end of the line. Okay, so let's comment out these three so we don't cause any errors, because we haven't actually got any information populated here at the moment. So I'm going to save that, and now what we need to do is we actually need to create code to check our winning lines. So if we look, let's do the horizontal lines first of all. So we're going to have to create horizontal patterns. We're going to have vertical, patterns, and then we're going to have diagonal. So this is the different ways that people can win. Okay, and each one of these has to be 3 squares. So let's start with this. So we can technically have 1, 2, or 3 lines. So we're going to have H1. We're going to have H2. Obviously H for horizontal, and we're also going to have H3. And I'm going to just do the same down here. We're going to have V1, V2, V3, and then obviously we can only have 2 diagonal lines. Diagonal 1, which is going to be top left to bottom right, and then we're going to have diagonal 2, which is going to be top right to bottom left. Okay, so these are all the patterns that we actually need to identify. So what we have to do is we have to check each box for the character that we've received in, that we've already placed on the screen with that print line. So we know what that is. So we're looking for, is box 1 and box 2 and box 3 all containing a cross, for example, and that's going to determine a yes or a no. And if it's a yes, we draw a line. If it's a no, we do nothing, and the game continues. So we literally have to repeat this same pattern now for each of these different, basically 8 possibilities of a winning line. Okay, so if you remember down here in our watch square tapped, we did have a line, if I uncomment that printed out the entire status of the array, where has it gone, array board, okay, because we've been looping through it, updating it. Okay, so if I just quickly run this now so I can show you the information, and we know that this board already exists, so we've kind of got the code going on already. So let's tap on the screen. There we go. So you can see that box 1 has crosses, box 2 has noughts, and obviously this is now printing out every single time this is updated. So as we go through it, now forget the win, lose or draw, that's just a little updated statements, that's just me up here just checking what's going on. But we can go through and every single field now gets a value, okay? So if we copy this code down here, so we're going to literally copy this entire line, copy, because we actually need to identify the squares, and I am going to come down here and grab this line and pop it up here just so that we can check what's going on in this location, end. Okay, what we need to do now is we actually need to grab each object out of the array and populate it in a local variable so that we can work with it and use it to check its status. So we are going to quickly do an if statement. So if object number is equal to 1, then, so I'm just going to create up here, before I go any further, local variable object 1. So we now have a local object variable that these squares can live in as we grab them out of the array. So if object is object 1, then object 1 is equal to the object, else if. And the reason I'm just writing this all on one line, because it's just going to save a little bit of space on the screen. Object. So I'm going to just copy this, and I'm going to just tweak it as we go. 2, 3, 4, 5, 6, 7, 8, 9. And then we're going to just change that to object 2, object 3, object 9, and then obviously end. Just so that I've kind of finished off that if statement there. And all I am doing is grabbing every object. So I'm going to circle through the array. I'm going to grab its index. I'm going to grab the item that we've stored there, which is in this case an object, which is the square grid. Okay, and then I'm going to print it to screen, just so that we can see what's going on. So we're going to create its status and its number. We are going to get every object, the current one being used, and if that is 1, then we put it into a local object 1, okay, so that we know which square we're working with, and we'll be able to test it in just a moment. And obviously I've put the object itself and not one of its statuses or its names or its number, because the object has all the information about it, including its location, those X and Y's values that we're also going to need to know. So by placing the object inside, once we've retrieved it out of the array, we're going to place it in its local object. It means that we'll be able to have all of that data related to that specific item. So I'm just going to save that and make sure that we've got no errors at this point. Now that we've got this going on here, what we need to do is we now need to search basically for a pattern. Let's just say, for example, we're playing with this scenario. Okay, so there has been 5 turns. The red nought went first, second, third, fourth, fifth, but at the time of placing the 5th item on the board, it now formulates a row. We can see this as humans, but what we need to do is get this board game now to identify it. So this is essentially horizontal line 1, which is what we're going to identify here. First of all, we're going to be working with lots of if statements again. So if and we've got the character in, if character in is equal to the object status. Now, instead of this object, what we need to do is test for the line. So we're going to actually call it object 1 status. So say that's a nought and that status says noughts. Okay, we're doing really well. So we then need to see, okay, is box number 2 doing the same thing? So I'm just going to copy this. And we need to check that the character in box number 2 is the same, and number 3. Okay, so remember back at the beginning when we designed our board, we placed them 1, 2, 3, 4, 5, 6, 7, 8, 9. So the first row or winning line is going to be contained in box number 1, 2, or 3. 1, 2, and 3, I should say. So what we need to do is make sure that the character, say for example it's a nought, the status of that object is a nought in box 1, box 2 is a nought, and box 3. So we need to do a comparison against what we are looking for as a winning character and all 3, okay? And if that is a success, then we can print the word, for now, winning line 1, okay? Because obviously then we've got to send the information in a minute up to our line, okay? So just to make this a little bit easier, I'm just going to, you might have to zoom in on this a little bit, but as this line is quite long, I've just made the text a bit smaller, so I hope you can stick with me on this. So we are now going to copy this and we're going to put it here for line 2. But this time we're going to change the numbers, because obviously we're going to look for lines that this is going to be box 4, 5 and 6. Okay, now I'm just going to stop there because obviously you get the idea now. So we're going to repeat this with the verticals. So that would be box. So V1 would be 1, 4 and 7. V2 will be 2, 5 and 8. V3 will be 3, 6 and 9. And then diagonal will be 1, 5 and 9. And diagonal 2 will be 3, 5 and 7. Okay, so you can copy this same pattern now and repeat it down all of these steps. Okay, so when we test this now, it's causing an error. And it's saying that object 1 has a nil value. So something up here, object 1. Oh, it's obvious. Look, I'm looking at a string because I've put it in quotes and I'm comparing it to a number. So if I take out see, it's such a tiny little thing. You've got to keep your mind on the game all the time. So let me just come out and just correct my code. So apologies for that, guys. It happens to the best of us. I'm going to save to make sure it's updated. And then it says, do you want to relaunch the project? Okay, so the game now is printing to the console a winning line statement. So we know that it can identify a winning line, but something that I've also just picked up on is the fact that as we create our game and we create a winning line, technically we should be stopped at that point in time. We shouldn't be able to then play another character, which we can. So we need to resolve that problem. And also we need to look at the fact that what happens when all 9 fields are actually occupied and there isn't a winning line. So we've still got 2 more things that we have to basically manage at the moment before we can print that line on screen. If I just come out here real quick and I close this project and I show you what we did in the first game, because I'm kind of, instead of actually handling directly the, say for example, maybe removing the event listener of all the squares, what we're going to do is I'm going to show you the one that I've actually launched. So here's my game, and we'll add sound effects and things in later videos. But if you look, I play a little sound effect and I've got an overlay come up, and now I can't actually tap on anything underneath, even though we can semi-see it and this overlay is semi-translucent. The only thing I've got is this little button that allows me to remove that overlay, but if I slide and let go of that, the overlay comes back. So in this manner, I'm now controlling what my player is able to do underneath. Okay, so that will solve that problem. And the second thing that we still need to solve is what happens if there's a draw. Okay, so let's come back to our game, close this one, and then come back over to our Tic Tac Toe. Okay, so what happens if we are clever enough to create a situation where there are no winners? Okay, we need to now have, obviously there's no winning lines come up. What we need now is a situation to establish a draw or a stalemate situation. So let's handle that first, because that would in itself also make an overlay pop up to say, uh-oh, no winners, try again. Okay, so I think the easiest way that we can tackle this is, obviously we've got 9 grids and we can easily see with our eyes if those 9 grids are completely full up or empty. So let's start off now by creating a local variable here, number empty squares. Okay, and we know when the game is first launched there are 9 empty squares. Right, so now that we've got these 2 variables, first of all, this is going to count down how many empty squares are in here, which we'll do in just a moment when we handle the draw. But for the moment, let's handle the results. And we're going to get the result of this. This is going to hold a true or false value, like it's either drawn the line or it hasn't been able to. So if we call draw winning line, okay, and this is where we can send it, because we now know object 1 and object 2. So if we was to send it, object copy, so we've got to go in the order of x, y, x, y. Okay, so from the starting object, which will be object 1, okay, we're going to do object 1 dot x, and then we're going to also send it object 1's y position in. So let's just change the y. So that's this first object. So let's refresh this board. Let me save this and let's refresh this board so you can see what we're actually programming. So relaunch. So we are now doing H1. So that's this winning combo here. Okay, so this winning line here. So we know the first box is box 1. We know the last box is box 3. So we also need to send it object 3. So we now know where the line starts and where the line finishes. And then up here we have got the ability to draw the line. So as we now can uncomment that, we will now add this object, this line object, to the group board foreground, giving it an X and Y and an end X and Y. And all I'm going to do now, just to make sure it sits above everything else on the screen, is I am going to make sure that line is to front. So we've only created the result for the first line, and if this principle works, then I'll duplicate it down and just change the object references to match the first and the last one of each winning combinations. We're looking at object 1, object 2 and object 3, and it creates a winning line. So all that's happening now is this result here is basically, we've got to just handle this in a moment, but drawing winning line is sending it the X and Y coordinates of object 1, the X and Y coordinates of object 2. That's coming up here. This information is being received in. Okay, we can see that it's drawing a winning line, which is what that statement there does. Then we've got the line itself using the display API library, where we're putting it in the board for the group foreground. There's the X and Y coordinates. We're making the line black and semi-transparent by 50%. Then we're making the width of the line 30, and we're making sure it's at the front, which means it's sitting on top of our players' characters. And there we go, we've got our winning line. So it now works. So we now know that this situation here works. So what I need to do now is for the next couple of minutes is just copy this down here. Copy, and I literally just need to alter it for each various combination. Okay, so now all our winning lines work really well. Okay, we still have one more thing left to do, and that is to handle what happens if we get to a stalemate. So first of all, we've got this result here. We actually need to give this result. So when we come up here and so our check, win, lose or draw gets a result variable, and we're putting a value here, but what we need to do is actually return back the word true. So we've finished the command and we know what's going on. So where's our winning line? And we can put here as a function return true. So we've done it. Okay, so this now will return the answer and contain the result true. And if we look up here, if we set this to false to start with, it contains the word false. So we now got something that we can test on it. So if result equals true, and we're going to need to test these number of characters, aren't we? The number of squares. We need to do something to that. So let's say number of empty squares is equal to 0. Then we need to print the word draw, and then we can send it as a message, text to the screen. Oh, no winners. So obviously, as we already know that the squares are empty or not because we've got their status going on here. So all we really need to do is update or take away every time we find an empty square, so the information's already on our screen. As we create the object, we just need to check its status. I'm going to put check status. Okay, so up here I'm going to put local function check status end. Okay, we've got number of functions equals number of functions minus 1. So so as we call the object, we send the object status up here, we've just got a little local function, and all that is doing is checking for the non-empty spaces. So basically we've got 9, and for every time it finds a non-empty space, so say for example I put in a character here, obviously this is now not empty, so it's found one of them, and it means that we can just count down from 9 to 1, and that gives us the result of the number of empty squares left. So obviously if we've got 9 boards, we've got 1 filled, that means we've got 8 left, and that is what is showing over here on the console, which is why this console is just a fabulous thing to have. And just to prove it, if I put a second character on there, we're now looking at 7 empty squares, and obviously you can see that it's gone through the whole process again. Then we've got 6 empty squares, so it's there, and we're looking at the noughts character, and then we've got the crosses character this time, but now there's only 5 empty squares, and so on and so on and so on. So we now know that number of empty squares. So if we keep going, so that we don't get a win, she says, trying to remember. Okay, we can get down to 0. So there's now no 0 means there's no empty squares. So we know that this is being populated correctly, okay, and it's living up here still inside the check, win, lose or draw function. So now that we know that the result is false or true, because it's going to put true if it draws a winning line, or that the result there is empty or 0, down here we can now check for the result being is equal to true, and no, it needs to be false, because obviously there is no winning lines and there are no empty squares. Then we should be able to put this message on the screen. So let's have a look. So let's try and get a draw situation again. There we go, and now we've got a draw. So that pretty much, It's been a bit of a long one because there was quite a lot of factors that we needed to do, but we now have a draw on the screen. So over the next video, what we're going to do is now look at creating an overlay, which is a scene that sits on top of the other scene, the one that's the actual gameplay, and we can see it as a semi-translucent, and it controls the environment. So we can't access things on the bottom scene, we can only access the top scene. So just as we did on that example a little minute ago. So it's been a bit of a long one, I am sorry about that, but sometimes you have to go through these processes to be able to explain, because there's so many intricate little details going on in this game. But if you've got any questions or any comments, please put them below, and do remember to subscribe and click that bell to stay notified, and I will answer your queries as best I am able as soon as I come across your comment. Thank you very much for watching, and I'll see you on another video real soon.